4, 1. That's a harder question. You're not given the center and the radius. So you have to go find them first. So we don't have the center and the radius. We have to find them. Find the center. Find the radius. And then you're in good shape and you just go do exactly what you did above. So a diameter is, the line that goes through the center. So we have a circle, say centered here, and something like that. Diameter has to go through the center. And these points are on opposite ends of the diameter. How do you suppose we'll get the center? The midpoint of that line segment is exactly the center. Very good. So to get the center, we have to find the midpoint. Very good. And the formula for midpoint, you remember, is take the average of the x's and the average of the y's. Add up the x's, divide by 2. Add up the y's, divide by 2. Okay, so what's that going to be for us? When we add up the x's, what do we get? Oh, I don't like it. 0, 0. Look at the origin. All right, I have to pick one. All right, the origin is the center. Negative 4 plus 4 is 0. Negative 1 plus 1 is 0. When you add up the x's and y's, you get 0. So you divide by 2, so what? It's still 0. So this is your center. Darn it. Sorry, I wanted one that came out a little better. Oh, it's okay. And then what about the radius? I think we'll find that knowing these 2 points at opposite ends of the diameter. Distance. The distance between the 2 points will be the diameter length. We need the radius length. If you have the diameter, how do you get the radius?
The distance between the center and one of your
Oh, that's another way to do it. That's what you're saying. I'm sorry. I thought you were talking about the distance between the original 2 points. Yeah. Take the center, which in this case is nice 0, 0. Take either one of the 2 points. Doesn't matter. And that distance is the radius. That works out. Let's do that. Since we found the center first, find the distance between the center and one of the points. That works out better. Alright, so let's pick the point that's all positive, 4, 1. So if the center is 0, 0, and the other point is 4, 1, then using the distance formula, we subtract the x's in square, subtract the y's in square. What's nice is we're subtracting nothing. So we get 4 squared and 1 squared. And we add those up before taking the square root. What do we get? Square root of 17. That's the distance, and that's our radius. But that's okay, because if we have to square the radius on the other side of the equals, squaring the square root, you just get what's underneath. So when it comes time to go with the equation, h is equal to 0, k is equal to 0, r is the square root of 17. So, you can start off by writing like this, but subtracting nothing is just taking and squaring the x only. Subtracting nothing on y is just squaring the y only. And then root 17 squared is a 17. So that's the answer there.
What equation is that? The h equals 0, k equals 0?
These are my individual guys I'm going to plug into, plug into that, H, K, and R. Yep. Here, this was H, this was K, and this was R. Those are the three things you need. Okay? And if that wasn't complicated enough, there's one more thing we could do. We might have to complete the square. To find this equation. It's not in the standard form where it has those perfect squares, you know, x minus something squared, y minus something squared. We don't have that. So we have to complete the square. We didn't use this. We could have used it back when we were doing the quadratic formula, but we didn't use it then. But we're going to use it now, though. Our goal is to have, you know, the standard form is x minus h quantity squared. That's a perfect square. Y minus k quantity squared. That's another perfect square. And then on the other side, some r squared. And so we need perfect squares. We don't have them. We're going to make them. Okay? If I tell you x minus 8 quantity squared, if you were to multiply that out, what you notice that we'll get x squared minus 16x plus 64. There's some relationship between these three numbers, the negative 8, the negative 16, and the that's okay. And the positive 64. There's a relationship there. And it's that relationship that we need to work backwards. We're going to start off with maybe only parts of this. And we have to add something so that we end up with a perfect square. So we have x squared minus 2x. And we like to add something so that we have a perfect square. And it's all about the relationship between those three numbers to figure out what we're adding, what goes inside the parentheses. We're just dealing with this one number right now, minus 16. We have to figure out, well, how can we backtrack and get that minus 8? How can we backtrack and get that 64? And the relationship is that whatever's in this spot, the number that goes in that spot is just half of it. So whatever's here, we take half of it, and that's what's going to go in there with the perfect square. So half of negative 2 is a negative 1. So it's x minus 1. Well, that's what our perfect square is. Well, how do we get that 64? The relationship here between the 8 and 16 isn't directly related to the 64. You have to go by way of the 8. So we take half to get to the negative 8, and then we square to get to the 64. Unfortunately, 1 squared is just 1. And so that's a perfect square, but we physically changed the equation because we've added 1. Okay? But this is an equation. There's two sides to it, and so we'll add to the other side as well. Let me just set up the y part. Y squared plus 6y plus something. And we'll do it again. I like for this to be a perfect square. The relationship is whatever's in front of the variable, single variable to the 1 power, that coefficient there, we take half.